Okay, in class, hi everyone. In class, we made it to. I was working on this one, number 2 of, let's see, 12.6. And so, if you remember, this is the one where, from the book, they start with this WHO data, and really like show a whole pipeline of preparing data for here. In fact, I'll go one bigger. A whole pipeline for preparing data for use in ggplot or analyses of the sort that are really easy using the tidyverse. And so maybe just I'll kind of go through this line by line again, so that those, I mean, it was pretty quick. In this way, you can sort of rewind if you need to and figure out what's going on. So we have WHO data, and again, I really recommend a great way of doing this. You know, the one of the great benefits of using dplyr and the piping system is you can just erase a pipe and often see exactly what the data looks like before you do anything. So we have this data. It has a country, two ISO codes, a year, and then it has these. So it's the variant. Is that right? The variant, and then age, sex, and an age. So this is 0 to 14, 15 to 24, and so this is the new cases of this variant for this age group and this sex. So it's like really ugly, right? It's a whole bunch of columns, 60 columns. So it's really kind of it's not in a format that is amenable to data analyses. But we are going to fix that. And so the first thing that we'll do is pivot longer. So we want it to be longer, right? It's really wide. It's got all these columns, and really a lot of the data that we want in as variables is in the column names. So for example, sex and the variant, each of those should be a value in a column instead of being part of the column name. So we don't want it to be this wide. We want it to be a lot longer. So that's pivot longer. And then which columns do we want? Well, we want to start with new SPM014. So we just look here, SPM014, and then we're going all the way to new rel F65, which is the last one. You'd have to kind of go through all of these, or do view of WHO. Here, I'll show you that really quick. View WHO. That'll open up this, and this is a little easier to navigate. You know, you can just go to the end. Oh, is it really? Oh, it's not even showing all the columns there. Okay, so now we're all the way to column 60. New rel F65 is the last column. So in other words, this is all the columns after the first few. So the names of the column, the names of this new column. So it's going to take all of these, make it into one really long column, where the name of the column becomes the key, it gets put in a new column called key, and the values from that column get put into cases. And then we are also going to drop the missing data, because in this case, well, we don't know why it's missing. I believe there are zeros, right? One of the questions talks about this, but there are zeros, which tells us that if there's nothing there, then it's okay to drop it. Like, we shouldn't impute values or something like that. Okay, so let's see what it looks like after this. Let's go down here again. So now we have country, ISO codes are still there, year is still there. And now for the column name got put here. So that's how it got arranged. The column name is now in key, and the value that was in that column gets put into cases. So we see for Afghanistan, there was no data before 1997, it looks like. And then we start to have data. So that's what the missing is, apparently, is just countries where there was no data collected. Yeah, so this shows all of these. You can see the year goes up, and we have data for each of the variants. Okay, so that looks good. But the problem now is that we would need to break up this key, right? So we have this new, which I think all of them say new, and then the variant's hidden in the middle here. The sex is in here still, and the age range is in here. So it's really a big mess. And so we need to take care of that next. And so the first thing we want to do is we have to fix one variant, which for some reason the rel one doesn't have an underscore, and that's going to mess us up later. So we want to fix that. I believe one of the questions is about that, like what if you don't fix it? So let's just see what that does really quick. We might not even be able to, I think we'll be able to find it. Let's see. Maybe not. Oh yeah. So these are ordered. Oh no, I bet we can. Sorry, let's see. Oh yeah, there we go. So now we have new rel. The only difference is this would not have had an underscore here. So that's all we're doing there. Now it has an underscore. And what that lets us do is in the next step, we can separate this key column into 3 new columns: new, var, and sex age. And so what separate does by default, we're not passing any other parameters to it, is it will just, anytime there's a non-alphanumeric character, so an underscore is not alphanumeric, it'll use that as an indicator of where it should separate things. So let's look at what that does. Just erase that. Now we have that one column got split into 3. So we have new, the var, and sex age here. Cool. So that looks good. That looks good. Now we almost made it through. The next thing that we do is decide that we don't need a few of these columns. We'll talk in just a second about this one, but ISO 2 and ISO 3 are different ways of referring to a country. So great. So we don't need those because we already have a way of referring to the country. So we get rid of those. We also get rid of new because all it is the word new over and over again. This one's very simple. It just got rid of those columns. So there we go. So now we have a country, a year, the variant, sex, age, and cases. So the last thing we want to do is break apart sex and age. And so we will do that. So this separates the column sex age into sex and age based on, so this where to separate is after the first character. So we know that the M or F is the first character, and after that is the age. So there we go. We have made it. We did it. We could, I mean, the one last thing that we could try to do if we wanted to is make this age prettier, you know, adding a dash or something. But it's a little bit tricky because it is not. So for example, 65 doesn't have, it's just actually 65 plus. So all the other ones have an age range and that one doesn't. And so it's the sort of thing where there's few enough of them that what I would probably do is just make a list of the strings that I wanted, you know, string of 0 to 14, and sort of replace the variables manually instead of trying to do something, you know, like separate or or anything too fancy like that. Anyway, so that's that one. And now the point is we have this in a format that could really work. And we'll see in just a second how to use it. So we have all these variables. These could be, you know, we can color something by sex, we can group it by country. We have all these things that we can do much more cleanly and easily now. Okay, so that looks great. What happens if you neglect the mutate step? I did this in class, but I didn't find a great way to show it, and so that's what I did here. So this just comments out the mutate step and then shows where it causes a problem. So we do the same pivot longer. If you remember, here I'll show what this looks like really quick. We have the country, blah, 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 and then we have the key column and the cases column. And so what we really want to do is break up this key column. And so if we forget to mutate, or we didn't notice that there were some that needed an underscore here, this is what we would get. We would try to separate it into these 3 columns. You know, we'd look at these first ones. Look, all of these look great. So I want to separate it into new, variant, and sex, age. And then let's see what happens if we do that. It actually looks great if we just look here. Oh, perfect, it worked, great. If we didn't notice that we also got a big error, a big warning message. It says expected 3 pieces, missing filled with NA, and 2,580 rows. So if you get something like this, sometimes it's okay, right? Some warnings you sort of expect and it's okay and you can ignore them. but don't train yourself to always ignore them. Like, make sure you understand what it's saying and why things might be missing. So this one is a big deal, and so it's saying it's filled NaN. And so what I did to figure out what's going on is just filter to where sex age is Na. So let's do that. So we do all those, and now we see what's going on. So we tried to separate into new, var, and sex age, but for these ones where it was actually new rel and there was no underscore, it put that whole thing into the first column, right? Instead of putting rel into the variant column, it kept it in the new column because there was no non-alphanumeric character to break it on. And so we have them all there. And so that's why we add in the underscore when we did that first mutate step. Because if you'll notice here as well, the variant is just wrong. The sex age got put into this column when it should be over here. And so, yeah. So that messed everything up. So we have to change the data before we do that mutate step. Okay, I think that one's pretty straightforward. The next one, I claim that ISO 2 and 3 were redundant with country. There are a few ways to do this. The strategy that I used was indistinct. So this is the number of distinct values, unique values in a column. And so what we do is we take WHO, group it by country, and then summarize ISO 2 codes is the number of distinct ISO 2 codes for that country. ISO 3 codes is the number of distinct ISO 3 codes for that country. And so if you look at what this looks like, it's a whole bunch of the number 1, right? So for Afghanistan, there's one ISO 2 code, one ISO 3 code. So that's great. That's perfect. That's what we want to see. And then finally, we filter to where ISO 2 codes is greater than 1, or this is remember the pipe is or ISO 3 codes is greater than 1. So let's find all the countries where either of those, there's more than one ISO 2 code or more than one ISO 3 code. In fact, what I really probably should do is do not equals to 1, because maybe there's some where there are 0 ISO 2 or 3 codes. So let's look at what that does. 0 rows return. So that's great. So every country has an ISO 2 code, one ISO 2 code only, and one ISO 3 code. So we can get rid of that data because it's not giving us anything extra. Okay. And finally, I think this is the last one. For each country, year, and sex, compute the total number of cases of TB. Make a visualization of how cases have changed in India, China, South Africa, and Indonesia over time and by gender. And then there's this hint that you can filter the countries. And so I actually do that right at the beginning. This is more important in larger data sets. But a good strategy is that if you're going to do like complicated operations on data, then put your filters first. Like filter down to the smallest data set. And then when you're doing group bys, when you're doing summaries, which can be really computationally expensive, you're doing it on this really small data set instead of on the whole data set and then filtering after you've done all that hard work. So it just makes things faster. Okay, so we filter to just those countries. We're going to do, and then we do all of the stuff we just did to make this the kind of data that we want to make it look pretty. Yeah, I mean, the other approach, which is totally fine, is if you think you might want data from lots of different countries, is you do, what we did up here, where we get the data, the way we want it, and you save that as a variable, right? You save the new data frame that has everything arranged the way that you want it, as WHO2 or something, or WHO tidy. Or something like that, and then you just operate on that data. But instead, I'm showing sort of the whole pipeline of what this might look like. So WHO filter to just those countries. Again, I'll show you just to see what that looks like. Now we just have China first. We only have 136 rows. And then we will pivot longer. This is all exactly the same. So I'm just going to skip past all of this up until here. So we separate it in the same way we separate it, we get it the data looks exactly the same, except it's only for these 3 countries. And then what do we want to do? So this is where I want to maybe pause. We want for each country, year, and sex, compute the total number of cases, make a visualization of how cases have changed over time and by gender. So what we want to think about is what we want first the visualization to look like, and second, the data to look like in order to produce that. So the visualization I am thinking will be well, I'm really thinking because I've already made it, but like a faceted plot of these 4 countries with the time as the x-axis, the number of cases as the y-axis, and gender is the color, or sex is the color. And so there's two different lines in each facet, one for each sex, and then 4 different facets, 4 different plots, one for each country. So what we need is to, so first we think of that. So what do we need? So we need a country. This is like the data that we need, right? We need a country that has a year, and then a sex, and then the total cases for that year, right? So I'm thinking about what we have now, which looks like, oops, that's our old one, which looks like this, right? So we have country, year, the variant, the sex, the age, and the cases. And so what we really want to do, and again, I think one really helpful way to think about this is to imagine that those are each this is like a bunch of index cards, right? That have this data. What would you do if you were in the real world? How would you do this? And so what we want to do is combine all the ones that are from the same country, year, and sex, right? So we gather those up, country, year, and sex. This is group by, right? We group by, we gather all of those cards up, and then we add them up for that year, right? Because that's what we want, is over time, we want to know the total for the sex for that year in that country. And so it's that 3 things, year, country, sex, add all those up, and that's the data point we want. And then we'll graph the whole thing over time. So how do we do that? Well, I mean, we group it, right? And I think that's the intuition that I really want you to get, is that when you are combining something you can combine it by multiple columns, you're grouping it by that column. And so we're creating, again, these like new mini spreadsheets based on those groups. Okay, so what does this look like? So we group by country, year, and sex. And if you remember, this is the one thing that's not helpful if you look at it if you just look at it. So we have country, year. It actually has all of the same data because grouping it doesn't actually do anything yet. We have to, summarize it or mutate it or something like that. So the next thing we do is to summarize it. So summarize cases equals the sum of the cases. So for a given country, year, and sex, unique combination, we sum all of the cases up. Oh, and it just tells us that it's now grouped by country and year. Okay, so we have this new data frame that is country, year, sex, and cases. And it looks great. That's exactly what we want. And so for each country, we should have, 2 entries per year. So China has a female and a male entry in 95, and it's the total number of cases. So perfect. And then we're ready. This is exactly the data that we want. And so now we can pass it to ggplot. So we'll do that. The x-axis is the year, the y-axis is the number of cases, color is the sex, and we make a line. Let's look at what this looks like at first. That does not look good. That is not what we want. What's going on here? Let's see if we can figure it out. So what if we add in the countries? What does that do? We facet by country. Okay, that's what we want. We want it to look like that. So why was it doing that weird thing when we did not yet do a facet wrap? What in the world is going on here? So the answer is that it is plotting. It's trying to draw a line between multiple points for a given year, right? So this represents maybe, this is female or male for China and Indonesia. So this is sort of the range, right? So there's going to be a point here for China and one for Indonesia and one for et cetera for India. And so we have all of them on there, and it just tries to draw a line between all of them. So this is like the min to the max for the year, which is not where we want, right? So we need to figure out a different way to change it by country. And so I did facet wrap. You could do something like different line style. Actually, don't even remember how to do that. I have to look that up. So so we facet by the country, and then I also, you know, I'm like kind of obsessed with these viridis, or however it's pronounced, colors. I played around with the way I wanted it to look, and you can kind of change where it starts and ends. And I think this looks pretty nice overall. Oh, the one other thing I would change is the scale here, because yeah, we don't want scientific notation. I'll show you how to do that too. In fact, I'll pause the video so I can look it up and make sure I remember how. But yeah, the rest of it looks really good, right? So we have these nice comparisons and comparisons by sex over time for all of these countries. I think it looks great. Okay, let me pause the video. I'll be right back when I figure out how to change that scale. Oh, okay. Oh, sorry about that. I thought I hadn't yet started the recording again. Hopefully I did not record that whole time, and you saw me goofing off trying to figure things out, probably picking my nose. Okay, so I figured it out. There are a few ways to do it. What I think is the simplest, there's this library called Scales, which you may have to install, right, with install.packages. It lets you do a lot of cool things with Scales. It's especially nice for dates if you have a whole bunch of dates. And so, like here we just have years, so they're spread out nicely. It works great. But if you have a whole bunch of dates, it like does a nice job with that. I've used it before for that. You should look that up. Shoot, I don't remember what the function's called. Anyway, we're going to use Scales, and then we scale the y-axis. So scale y, and then you need underscore what kind of axis it is, which is kind of a pain, but this is a continuous axis, right? And then the labels, we just want to change them into, this comes from scale, it's called comma. So it's the comma style of labels. And so I think this is a really nice one. So it adds these comma separated nice labels, so of how many cases there are. Yeah, so that is my approach. I think it looks pretty nice. I think it does what we're trying to do, and shows nice patterns across these 4 countries. All right, I hope that's helpful. Let me know if you have questions.